algebra students. Mr. Lawrence here with your Philip lesson, and we're going to be doing a little more of multiplying and dividing rational expressions. Now remember, the key to doing these is factoring. We got to look to factor. If you can factor them, they're really pretty simple. I think they're pretty cool. But factoring is the key. Yes, the big F word is the key for this. All right, let's get down to it. I'm only going to do 4 problems, 2 multiplication and 2 division problems. We're getting lots of practice. Pardon me. I would expect some kind of quiz near the end of the week. All right, well, first of all, problem number 1, x squared minus 9 over x squared plus 6x plus 9 times x squared plus 3x over 5x minus 15. Well, I'm going to factor this numerator here, and I know that it's the difference of perfect squares. So it'll become an x plus 3 in a quantity and an x minus 3 in a quantity. The denominator is actually a perfect square trinomial, right? If you want, you can think about it this way. I need 2 factors of 9 that add to get 6. 3 plus 3. I'll factor as x plus 3 and x plus 3. All right, times. Now to factor this one, it looks like I can only GCF it. So I'm going to pull out an x. There we go. And to factor this one, again, it looks like a GCF type problem. So I think the GCF is 5. So I'll factor out the 5 and I'll be left with an x minus a 3. All right. So now we are going to go ahead and simplify whatever we can. Remember, we're going to simplify vertically on both sides. And then we'll go diagonally down to the right and up to the right if we can. Okay, so, excuse me. Sorry, my allergies are kicking up. I'm out on the farm in Indiana making this video, saying hi to the cows. Moo. All right, here we go. I'm going to look vertically, and I see an x plus 3 and an x plus 3. So those cancel out. They're gone. They turn to 1. When I use 1 in multiplication or division, nothing happens. So they turn to 1. All right, I can't cancel those because they're not the same number. Let's look vertically here. I don't see anything that'll simplify here either. Now I'm going to check down to the right. And look, I have an x minus 3 and another x minus 3. So now my left fraction has become plain old 1. 1 over 1. It really looks like this. 1 over 1. Oop, not 1 over 1. Silly Mr. Lawrence. 1 over x plus 3 times x times quantity of x plus 3. Now, you don't have to rewrite it at this point if you're having, over 5 of course, if you're having difficulty seeing, I thought I'd rewrite it to show you what's going on. So now, I've checked all directions except for the diagonally up to the right. So I need to check this way. Well, I have an x plus 3 in the denominator here, and I have an x plus 3 in the numerator. They can cancel. So now I'm ready to multiply. And I have 1 times x, which is x. And I have 1 times 5, which is 5. Now, by the way, this is only true when x cannot equal certain numbers. So let me go back and check what numbers. I'm going to highlight the places I had defined. Okay? So for example, this is an important quantity. This is an important quantity. And this is an important quantity. If any of those quantities turn to 0, then the fraction they're a part of is undefined and I can't do any operations with it. So, all right. So when is this quantity, x plus 3, equals 0? Well, a lot of you can tell me, but if you're not sure, here's how you show the work. So x cannot equal negative 3. Now, this one here is the same restriction. I don't need to list it twice. But then I have an x minus 3 over here. Well, will x minus 3 equal 0? Well, I think that'll happen when x is 3. And so therefore 3 is the other restriction. And there is my answer. What it means is that the original multiplication problem is the same thing as x over 5 when x is not 3 or negative 3. Otherwise, they're not the same. Okay, I want you to try number 2 on your own. Going to factor it, simplify, multiply, and then state restrictions. Okay, factor, simplify, multiply, state restrictions. Unpause the video when you're ready to see my solution. Okay, first of all, here comes my solution. I'm going to factor this guy. I need 2 factors of 10 that subtract to get 3. Sounds like 5 minus 2. The only problem is 5 minus 2 is 3, but I want a negative 3, so it must be 2 minus 5. So this is going to factor as x plus 2 and x minus 5. Now for the denominator, I need 2 factors of 7 that add to get positive 8. Well, 7 and 1, silly. X plus 7, x plus 1. Now if you're like me, you're already looking for things to cancel. I don't see anything at the moment, but I'm making mental notes. Now I'll factor the numerator of the second fraction. I need 2 factors of 35 that subtract to get positive 2. 7 minus 5 sounds like it'll work. I'll have an x plus 7 and an x minus 5. Ooh, I see something that will cancel. All right, in the denominator of the second fraction, looks like a GCF situation. And so I will pull out a 3x, and then I'll have an x plus 2 left. All right. Now I'm going to look to simplify in all 4 directions. 1, 2, 3, and 4. I don't have to go in that order, by the way. Now, I already checked vertically on the left. Nothing's going to happen. Checking vertically on the right. Nothing is going to happen. Diagonally down to right. Looks like I have the number x plus 2. And I have the number x minus 5. Or I could say it has 2 more than x, 5 less than x. This is the number 3x, 3 times x. And this is number 2 more than x. Ooh, I've got a common factor. Bye-bye. Now I'm going to check this way. I've got the number 7 more than x and 1 more than x. And here I have 7 more than x and 5 less than x. Okay. Well, my numerator, there's nothing left to cancel. My numerator is going to end up being x minus 5 over x, or times x minus 5. I could FOIL that, but I'm not going to. I'm going to leave it in factored form because it'll be easier for the reader to know that it's simplified. My denominator is going to be a 3x times the quantity of x plus 1. Now, don't forget to state your restrictions. It's only true when x cannot equal certain numbers. Well, let's see here. I got to check this quantity, this one, and this one. Looks like I'm going to have a lot of restrictions on this one. Okay, x cannot equal, when is this quantity 0? Well, when x is negative 7. When is this quantity 0? When x is negative 1. When is this quantity 0? When x is 0. When is that quantity 0? When x is negative 2. So I actually have 4 restrictions. So the product is equal to, whoa, x minus 5 times x minus 5 over 3x times, having some things going on here, but I think I fixed it. The product is equal to this fraction only when x does not equal any of those 4 numbers. Okay, let's do 2 quick division ones, so this video doesn't go too long. I'm going to do the same thing, only remember that with dividing by a fraction, I have to multiply by the reciprocal. So I'm going to change this to a multiplication problem, and this guy is going to flip. So he's going to be x squared plus x minus 12 over x squared plus 5x plus 4. So I really have this problem here. Okay, so the numerator of the first fraction, I need 2 factors of 8 that subtract to get 2. Well, I think 4 minus 2 will work. So x plus 4 and x minus 2. the denominator. I need 2 factors of 6 that add to get negative 5. Well, I know it's going to be a 2 and a 3. And remember, when there's a plus in the back, it's the Wendy's double stack. Bam, bam. All right. The numerator of the second fraction. I have 12. I need 2 factors of 12 that subtract to get positive 1. Sounds like a 4 minus 3 deal to me. A 4 minus 3. In the denominator, I need 2 factors of 4 that add to get 5. How about 4 and 1? All right, now I'm ready to do my canceling. I can go x plus 4, x plus 4, minus 2, gone. Let's see here, x minus 3, x minus 3. I don't see anything else that'll cancel. I combine my numerator to get x plus 4. My denominators give me x plus 1. And I know x does not equal 2, 3, negative 4, negative 1. So x cannot be negative 1, negative 4, 2, or 3. There are 4 restrictions. One more problem. They're done the same exact way, multiplication, but you got to remember to multiply and flip. And we've talked about in class why that is. All right, so I'm going to rewrite this problem here. Notice my second fraction is in the process of flipping. It's flipping so much it's like a pancake. Oh, I like pancakes, especially with chocolate chips and real maple syrup. Not pancake syrup, real syrup. All right. Now, it is the same thing that we did in the first 2 problems. So I shall factor the numerator. And I'm going to do it kind of quick because I don't want this video to go any longer. Expecting you to catch on by now. Going to factor this one. And there we go. And sometimes we like to do that just to make it look a little bit better. And let me see here. It's going to be a negative 12 and a positive 1, I think. Ready for the canceling. X plus 1, x plus 1, x plus 1, x plus 1. X minus 5, x minus 5. My numerator's gone. Oh no, what did it turn into? Don't be silly now. Turned into 1. Because we divided out. Yeah, the numerator's 1. What's left in the denominator? X minus 12. This is true when x does not equal 5, negative 1, 12, negative 1. Already said that. Oh, you know, one thing I didn't mention on problem 3, and I really needed to, I also need to check the numerator here. And I'll explain why. Sorry, I missed that. Hold on a second. I'm checking restrictions here, 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 and here. And what I'm saying to you is in this problem, I have to check this one because he used to be in a denominator, didn't he? So I need to check that one. Now, in this case, it doesn't matter, but I might have missed a restriction up here. So let me see here. Let me go back and see if I checked all my restrictions. Let's see. I checked this one. I got 2. Check this one. I got 3. Check this one and I got a negative 4. That one got me a negative 1, but now I need to check both of these. Unfortunately, that'll get me a 3 and that'll get me a negative 4, so I'm okay. If there was another number there, like say like x plus 6, I'd have another restriction. All right, that's the video for today. Mr. Lawrence signing off. Good night, everybody.